Physical change. A substance is usually identified by its physical properties, by its shape, size, color, state, etc. We know that water is wet and gold is shiny. That is how we identify them. When there is a change in any of the physical properties of a substance, its shape, size, color, or state changes. This type of change is called a physical change. No new substance is formed in this type of change. It is usually reversible.
Take a piece of paper and crumple it. What happens to the paper? The original shape of the paper changes because you have changed the body of the substance without changing its composition. You have only changed the appearance but not the composition of the paper. So, you have not made a chemical change but a physical change. Take chalk and crush a small piece of chalk into dust. Add a little water to the dust to make a paste. Roll it into the shape of a piece of chalk. Let it dry. Did you recover chalk from the dust? Yes, you will obtain the chalk. This kind of change is a physical change. Take some ice in a glass or plastic tumbler. Melt a small portion of ice by placing the tumbler in the sun. You have now a mixture of ice and water. Now, place the tumbler in a freezing mixture, ice plus common salt. Does the water become solid ice once again? Yes. Water changes to ice on cooling in freezer. Take some ice cubes out of the freezer and put them in a beaker. Leave the beaker for some time. What would you observe? The ice would turn into water. That is, the state of the matter would change. You want to inhale steam. As you have a cold, you would still have the remaining half measure of water. Pour the remaining water into a suitable vessel and put it on a lighted gas stove. The water would start turning into steam. That is, the state of the matter would change again. Thus, you would thrice have changed the state of water, only to find that it was a physical change and hence reversible.
Understanding chemical change. A chemical change is a process in which substances are changed. Chemical change occurs whenever compounds are either formed or decomposed. During a chemical change, a chemical reaction takes place. A chemical change is permanent and is therefore irreversible. For example, burning a log of wood. It turns into ash, and the resultant ash cannot be changed back into log of wood.
Take a piece of magnesium ribbon and burn it over a flame. The magnesium ribbon burns with a brilliant white light. You will notice a white powdery ash left behind when the magnesium ribbon is completely burnt. Collect the white ash and drop it into a beaker containing 30 ml of water. Stir the water thoroughly and test it with litmus paper. It turns red litmus into blue, while blue litmus does not change the color. You can conclude that magnesium on burning in air forms a new product, that is, magnesium oxide. The change proceeds with the evolution of heat and light. The change is permanent and irreversible. The magnesium oxide is added to another chemical reaction, forming magnesium hydroxide which is basic in character. A beaker is half filled with water. A teaspoon full of copper sulfate is added to it. A few drops of sulfuric acid are now added to the solution. Do you notice that a blue-colored solution is formed? The solution is divided into two parts and is kept in two beakers. Iron nail is dropped into one of the beakers. Wait for half an hour or so. What do you observe? Now compare the color of the solution kept aside in the other beaker with the color now formed in the solution. Do you notice any change in the nail after it is taken out of the beaker? A brown color of copper deposit on the nail while the color of the solution is changed into green. This is an example of chemical change. Let us observe another reaction to see a chemical change taking place. 1 tablespoon of baking soda is added into 100 milliliter of water into a beaker. It is stirred well till all the baking soda is dissolved. 5 milliliter vinegar is then taken in a test tube. With the help of a dropper, a drop of vinegar is put on a strip of red and blue litmus paper. Now, add at least 5 drops of baking soda solution to the test tube containing vinegar. Bubbles are seen to have formed due to evolution of carbon dioxide. The mixture is stirred till the bubbles stop. Again, test the solution with red and blue litmus paper strips. Since vinegar is acidic, it turns blue litmus red. When baking soda is added to it, the new solution does not affect any change of color in any litmus paper because it has become neutral in nature. The vinegar, acid, neutralizes the baking soda, base. Hence, this type of reaction is known as a neutralization reaction.
Let us study the difference between physical and chemical changes.
Rusting. Rusting is actually corrosion. Corrosion is the reaction between a material and its environment which causes the material to deteriorate and alters its physical properties.
Take a test tube. Fill it with water and immerse an iron nail in it and cover the mouth of the test tube with rubber cork. Keep it for a few days. The shining of nail disappears and it is covered with a brown surface. Iron is converted into hydrated iron oxide. Take 3 test tubes and label them A, B and C. Place small amount of calcium chloride in the first test tube to dry the air. Fill the second test tube with boiled water. The boiled water will not contain any dissolved air. Pour small amount of water in third test tube. Put iron nail in each test tube. Plug the mouths of all 3 test tubes with corks. After 2 or 3 days, examine them. You will find that nails in the first and second are free from rust, while nails in the third test tube have rusted. You conclude that water and oxygen are essential for rust. There are several methods by which corrosion can be prevented. Painting. The surface of metal which is exposed to air is painted. Paint forms a thin protective layer on the metal which prevents it from getting corroded. Alloying. Alloying means mixing 2 or 3 metals homogeneously with each other. Such metals, when alloyed with iron, save it from getting rusted. For example, stainless steel, an alloy of iron with nickel and chromium. Anodizing is a method of forming an artificial oxide layer of aluminium on the surface. In the process, aluminium reacts with oxygen molecule from the environment and helps prevent further corrosion of the surface. Galvanizing is a process in which the metal is dipped in molten zinc. Zinc metal covers the whole surface of metal articles or rod. By doing this, zinc helps to increase the resistance of articles and helps prevent corrosion by weather or environment. Dissolve some impure sample of copper sulfate in 100 ml of water. Filter the impurities out. Now, heat this mixture in a china dish so that the water evaporates from the copper sulfate solution and we get a saturated solution. The solution is covered with a filter paper and left undisturbed at room temperature to cool slowly for a day. We observe that the crystals of copper sulfate are formed in the china dish. This process is called crystallization.